Hello, class. I think this will be the last of the recorded lectures for section 4.5. And now we will take it up a notch and solve these equations with some of the other identities that we learned at the beginning of this chapter. And so what I mean by that is let's just go through a couple examples. And so let's do this one here. Sine of 2 theta plus cosine of theta equals 0. And so the idea here now is we're going to use the double angle formula. And when you do that, it's always handy to have all those formulas with you. And so when I look at that, I get 2 sine of theta. Whoops, put the 2 in the wrong spot. Sine of 2 theta equals 2 sine of theta cosine of theta. So we'll do that substitution. 2 sine of theta cosine of theta plus cosine of theta equals 0. So now we'll factor out our common factor of cosine. And so we have cosine of theta equals 2 sine of theta plus 1 equals 0. So again, we've done this before. Let's do it again. So first term, cosine of theta equals 0. And if you think about what that would be pi over 2 or 3 pi over 2. And then 2 sine of theta plus 1 equals 0. 2 sine of theta. To write an S and the 2 and the S in the same equals minus 1. And so sine of theta equals minus 1 over 2. So this would be in quadrants 3 and 4 with a reference angle of 30 degrees. And so when you take a look at that, right? So that would be 30. So that would be 210 degrees. And so this would be 30 over here, and that would be 330 degrees. So what is that in radians? So that would be 210, and that would be divided by 180 and pi. Boom, boom. 6 and 7. So that would be 7 pi over 6. And then the 330 divided by 180 times pi. And so this would be 11 over 3 goes into that 6. So that would be 11 pi over 6. 11 pi over 6. So if we take a look at the solution set, erase this up here. And so we have 4 different possibilities, right? So let's take a look at that. So possibility number 1 is pi over 2 plus 2 pi k, right? And this one is 3 pi over 2 plus 2 pi k. This one's 7 pi over 2 plus 2 pi k. And this is 11 pi over 2 plus 2 pi k. So when you take a look at this, we're going to add one more little level of complexity, is that sometimes you can combine these into a little simpler form. And so let me explain to you what this would do. Now, if you look at the first 2 equations, right? So if you think about it, what is the difference between pi over 2 and 3 pi over 2? So if you subtract those, you would get just a nice number of pi. So we could combine both of these equations into another equation that just would be pi over 2 plus pi k. You would see that when you add 1, you're going to get 3 pi over 2, etc. If you look at the difference between these two, it's not as nice, right? Because the difference between those two there is just 5 pi over 2. And it's not an ace multiple. So we usually just leave these the same as they are. So when I give you a quiz or an exam, if you don't combine those, that's okay. Mark it 100% right. But WebAssign here at the end is getting a little bit more picky about that. And they want to try, because mathematicians do like to write everything in its simplest form. So what's next? Well, there's half angle, double angle. We have the sum and difference formula. We have the sum and product formulas. And so all those are all fair game. So let's see. I think what I'll do now is pick this one. Sine of theta plus sine of 3 theta. And say we set that equal to a nice number, 0. So when you look at that, how do we combine that into something that we can deal with? And so in this case, this would be the sum to product, right? So this would be sum to product. And what that ends up doing is we're going to combine this. So this would be 2 sine of theta plus 3 theta over 2. And what's nice is now you usually want to try to get products, right? Because then you could pick each one of these out and set it equal to 0 in this case, and be able to solve for the angles. And so this one is cosine, and this would be theta minus 3 theta all over 2. So when you take a look at that, do a little simplification. It's going to be 2 theta, and this is going to be cosine of minus theta. And then we could do a little bit more simplification. Well, remember by the, what do we call that? The symmetry property, right? Symmetry property. That we can, since cosine is an even function, cosine of minus theta equals cosine of theta. And you would be tempted to maybe do the double angle formula here. But once you have everything multiplied together, right? If this equals 0, or if this equals 0, you're good to go, right? So we don't have to do any more simplification. And so the idea is, let's do the easy one first. Cosine of theta equals 0. And again, we've done that. That's pi over 2 and 3 pi over 2. So then the other one is sine of 2 theta equals 0. And so the way I like to think about that is a sine x equals 2 theta. And so so then you'd have sine of x equals 0. And where is sine 0? Well, sine is 0 at 0 and pi. So then we set x equals 0 plus 2 pi k, right? And then x equals pi plus 2 pi k. So you could see we could do a little sneakiness here, right? So what ends up happening is you can combine those, right? And so what you can do is can combine those, the x equals 0 plus pi k. And so once we substitute back in the 2 theta equals 0 plus pi k, and we divide everything by 2, you get theta equals, again, 0 over 2, which is 0, right? Plus pi over 2 k. So you usually don't write 0, right? But I did that just to make sure that we didn't miss anything. So let's see what we have. So just gonna give myself a little bit of room over here now. So what do we have over here? Well, I didn't finish the cosine, right? So cosine is pi over 2 plus 2 pi k, right? And it's 3 pi over 2 plus 2 pi k, right? And you see again, the difference between these two is pi. So we can simplify this as pi over 2 plus pi k. Then, so this is for the cosine. And then the solution for the sine is just pi over 2 times k. So you can see these two are almost the same, right? The only difference is what? This one has 0. See what happens when I plug k equals 1 in for the bottom one? It's just like plugging k equals 0 for the top. So you can see this most simplest solution is pi over 2 times k. And so that is going to be your challenge walking through the last group of these problems in WebAssign. What do you have to do? Well, you have to simplify the equation, typically using one of the identities. Sum and product will be used. Double angle, half angle formulas could be used, Pythagorean for sure. And now we add this last level of complexity. Write this equation in its simplest form. Combine all these angles into its simplest form. Very, very challenging. So again, get started on this early. Let me show you a couple examples that you will see. So here, you would use double angle or half angle as it says, and you can see this answer is 0. So use the double angle formula for cosine of 2 theta there. See, for example, this one here. You would use Pythagorean's identity maybe and cosine, another double angle formula. Here would be probably a half angle formula. Here would be sum to product, just like we used in the other one. And this was this one here, right? And so that would be, I just did that one. So that would be sum to product. And here we have another, this would be sum to product as well. And so that ends the recorded lectures for section 4.5. Hopefully these have been helpful.